So today we're going to talk about right triangles and Pythagorean theorem. A right triangle is a triangle with a right angle, in other words, a 90-degree angle. The hypotenuse is the longest side of a right triangle. It is across from the right angle, so diagonal from that 90 degrees. If we look at this example here we have leg A, leg B. Right here, this corner box indicates a 90-degree angle, or in other words, a right angle, and across from it is the hypotenuse. And again, if you see, that's the longest part of the triangle. So triangles with a 90-degree angles are called right triangles. The side across from the right angle is called the hypotenuse. This is going to be the longest side of the triangle. Again, that hypotenuse is the longest side of the triangle. The Pythagorean theorem can be used to relate the sides of any right triangle. Again, this only works for right triangle. This is very important. Only for right triangles. So that triangle has to have a 90-degree angle in it. The Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse. Now let's look at some triangles below. So here we want to test each triangle using the Pythagorean theorem to determine if the right triangle, if it's a right triangle. Do not just look at the picture. Looking at these pictures, it looks like a right triangle, but we want to use a squared plus b squared equals c squared to determine if this truly is a right triangle, if the lengths of each side are correct. So here we have 7 and 24 and 25. Again, the longest side of the triangle is going to be our hypotenuse. In other words, that's going to be our C. So when we set up our equation, we would have 7 or 24. Either one can be A or B. Doesn't matter which leg comes first, as long as you identify your C, the hypotenuse. So we have 7 squared plus 24 squared is equal to 25 squared. Now if we solve 7 squared, solve 24 squared and 25 squared, we get 49 plus 576 is equal to 625. Now we want to make sure that this is a true statement. So 49 plus 576 is 625, which 625 is equal to 625. That's a true statement. So yes, this triangle here with the lengths 7, 24, and 25 is a right triangle. Now let's look at the next triangle. We see here that we have 7, 14, and 21. Looking again, the longest side of the triangle is our hypotenuse, or C. So we want to set up our equation with each leg, remember the two shorter sides, so 7 squared, 14 squared, and see if that's equal to 21 squared. So we have 7 squared plus 14 squared is equal to 21 squared. Now evaluate each of the exponents, so we get 49 plus 196 is equal to 441. Now if we add 49 and 196, we get 225. 225 is not equal to 441, so no, this triangle right here is not a right triangle. Those lengths do not make up the lengths of a right triangle. Looking at our last example here, we have 12, 16, and 20. Again, the longest side of the triangle is 20. So that's going to be our C. So we have 12 and 16. Again, 12, 16 can be interchangeable for A and B. Does not matter, as long as the longest measured length is our C. So if we look here, we have to do 12 squared plus 16 squared equals 20 squared. Then we have 144 plus 256 is equal to 400. Now we want to see if 144 plus 256 is equal to 400. So when we add that together, we get 400 is equal to 400. So then yes, this is also a right triangle. So we can use the Pythagorean theorem to determine if a triangle is a right triangle based on the measures. Now on the back here on your practice, what you want to do is you want to find the missing side, or the missing length, and round it to the nearest tenth. So here are your steps. You want to write the formula a squared plus b squared equals c squared. You want to substitute in the values for a, b, and or c. So plug in what you know, square each substitute value, and then solve for the remaining variable using inverse operations. Again, here we have 2, 6, and across from that right angle is going to be our c. So we are here solving for c. So we have a squared plus b squared equals c squared. So again, we don't know what c is, so we're going to say a is equal to 2 and b is equal to 6. And again, it doesn't really matter which one is a and which one's b, as long as we know that c is the longest one. So here we're going to have 2 squared plus 6 squared, and see what c squared is going to be. So before we can solve, we need to figure out what 2 squared and 6 squared are. So we have 4 plus 36, and that's equal to c squared. So now here we know that 4 plus 36 is 40. So we know 40 is equal to c squared. And now our last step here, we see that c squared is 40, but we want to determine what c by itself is. So the inverse operation of squaring something would be to take the square root of both sides. So now we want to find the square root of 40. So the square root of 40. So when we do this, we get c is equal to 6.324, and so on. Now again, the directions tell me I want to simplify this to the nearest tenth. So if I look here, okay, I want to look for just this place value right here. I want to see if that 3 needs to be rounded up or can stay the same. The number next to the 3 is a 2, so that is less than 5, so it's going to stay 6.3. So our answer here is c is equal to 6.3. And again, that is our final answer. So go ahead and use the same strategies here for the rest of the examples on this page.